So let's see how this works. So integrating along here, we'll get I n plus 1. Then we'll get the integral up here. So this is height beta. We'll get the integral upwards, which we'll need to show goes to 0 up here. Then we'll get the integral back along here. So that will be the integral from infinity to minus infinity of, so we've got here z is equal to x plus I beta. So we've got x plus I beta to the n times f of x plus I beta, but f of x plus I beta is itself f of x. Then we've got the integral back down, which again you need to show tends to 0 as r goes to infinity. Okay, so, sorry, it should be n plus 1. So basically what happens is very similar to what happens with the log integrals. If we expand these brackets with the binomial theorem, then we'll get, first term will be x to the n plus 1. We've got limits infinity to minus infinity. Swap those, we get minus sign. So that's going to cancel this in plus 1, and we're going to get the first term will be minus I beta times n plus 1 times the integral we want, in, plus etc. all the way down to minus IB to the n plus 1 times I0. So it's very similar to what happens with the logs. So basically, and then of course this thing here is just the 2 pi I times the sum of the residues inside the contour. So we can then find in terms of in minus 1 all the way down to I0. Again, as with the log integrals, we can take real or imaginary parts to eliminate some of these integrals.